So, like I was saying, that air exists as a mixture because there is no chemical combination between the gases in air. There's no chemical combination between the gases in air, okay? The constituents of air. And what are those gases? You have nitrogen, you have oxygen, you have carbon dioxide, you have noble gases, especially argon. Then you have water vapor. There's no chemical combination between them. Okay, each constituent retains its chemical properties. I've said that. Then, how do you separate these constituents of air? Which principle is used? It uses the principle of difference in boiling points. And you remember that in separation techniques, any technique that uses difference in boiling point is distillation. Distillation uses the principle of difference in boiling points, where you take advantage of the boiling points of constituents of a mixture to separate them. Okay. In this case, now fractional distillation of liquid air. You know, the difference between distillation and fractional distillation is that distillation is employed if you are not separating too many constituents. You are not trying to separate too many constituents, one, and the range, the difference in the boiling points of the constituents you are trying to separate must be large for you to use only distillation, that is simple distillation. But if the difference in boiling points is close, like very close, for you to use a distillation, you should have at least not less than 20 degrees Celsius difference, not less than 20 to 25 degrees Celsius difference. But fractional distillation is employed when the boiling points are very close. So you use fractional distillation. So to separate the constituents of air, you use fractional distillation of a liquefied air. Okay, liquefied air. What are the steps? The first is filtration. Air can be filtered, of course. The first is filtration, then compression and cooling. That is the first step. Filtration, compression, and cooling. Then the next step is liquefaction. That's you liquefy the air. What is liquefaction? That's change in state of air or a matter from the gaseous state to the liquid state. Even though the liquid state will still be volatile, it will not be exactly liquid. That's what I mean. For example, the cooking gas that we use at home. If you check, you think it's liquid, but when you open it, it escapes in the form of gas. That is liquefied gas. Okay, so air can be liquefied too to be like that at very low temperatures. Then you now employ your fractional distillation. This fractional distillation will separate the constituents at their various boiling points. Nitrogen will come up first, being the lowest when it comes to boiling point. Now it has the lowest boiling point, that is minus 196 degrees Celsius. Argon follows at minus 186 degrees Celsius. Then oxygen at minus 183 degrees Celsius. You can see that these boiling points are close. Minus 196, minus 186. The difference between them is just 10 degrees Celsius. Then minus 183. You can see the difference between oxygen, the boiling point of oxygen, and the boiling point of argon is just 3 degrees Celsius. You can see that. So that's why fractional distillation must be employed. Then what is responsible for the difference in the composition of air in various places? I've just said that you can have different composition in different locations, different composition of air in different locations. What could have caused it? What would make this possible? Okay, what I'm saying is the amount of oxygen you have where you are right now may not be the same with the proportion of oxygen that I have here around me in the atmosphere, depending on certain factors. Number one, human activities. Human activities. You know, the level of pollution in different places are not the same, right? The degree of pollution is not the same everywhere. So, depending on human activities, So you can have different levels of carbon dioxide, carbon monoxide, sulfur dioxide. All these things will affect the composition of air in the environment. Then another one is vegetation level. Areas that are highly vegetated, uh, that has areas that have a lot of green trees, plants, and all of that, they have more oxygen than places that are like deserts. So vegetation levels affect oxygen and carbon dioxide concentrations. Humidity varies with temperature and water bodies. Humidity is just the level of water in air, okay, the level of moisture in air. Humidity varies with temperature and water bodies. So places that have water bodies are more humid than places that do not have water bodies, okay? Altitude also affects the level of oxygen and water vapor. Altitude, that is height. The higher you go, the lower the oxygen. The higher you go, that is the sky now. The higher you go up towards the sky, the lower the level of oxygen. Okay. Urban versus rural differences due to pollution. I've explained that just now. So the level of different constituents of air will not be the same. What you have at the rural area will not be the same as what you have at the urban areas. Then seasonal variations. Seasonal variations. Harmattan, how the composition of air during Harmattan is different from the composition of air during rainy season. So that's seasonal variation that affects the proportion of the constituents of air. All these factors are important. I've just mentioned human activities, vegetation, humidity, altitude, urban and rural differences, and seasonal variations. Don't forget that. So let's look at constituents of air and their uses. Constituents of air and their uses. You have nitrogen. Nitrogen has the highest proportion in air. Nitrogen has the highest proportion. You have nitrogen. And what are the uses of nitrogen? Fertilizer, ammonia production. Fertilizer and ammonia production. Food preservation. Cryogenic freezing. That's a kind of freezing that is okay. It's not like the one we use in our fridges, in our freezers, whatever at home. No, that one most people use a CFC. Most refrigerators use CFC or Freon. Okay, even though they also have been termed to be pollutants. Oxygen can be used medically, can be used in welding, can be used in the extraction of metals. Okay, oxygen can be used in the hospital. That's what I mean by medically. Oxygen can be used in the hospital for respiration. Oxygen also undergoes combustion. Okay, in the process of welding. The process of welding, if you have seen where a welder is working, that is a reaction between oxygen and oxyacetylene. That is ethine. Ethine is the same as acetylene. Okay. Ethine is the same as acetylene. When it reacts with oxygen, it produces that fire that you are seeing that they use in welding. We call that flame oxyacetylene. Oxyacetylene flame. That is another use of oxygen. It's very important in welding. Then oxygen is also important in extraction of metals. That's metallurgical processes. Carbon dioxide is used as a fire extinguisher. Is used in carbonated drinks, especially all those Cokes, all those Coca-Cola drinks, whatever. Uh, is in all carbonated drinks. That is why the taste, you like the taste. Yeah, that's the taste of carbon dioxide. It makes you want to drink more. But Coke has the highest. Okay. Then Greenhouse function for plants. Greenhouse function for plants. I've just explained what greenhouse effect means. I said greenhouse effect is the retention of heat due to the high amount of carbon dioxide in the atmosphere. Greenhouse effect. Okay. Then argon. Argon is a noble gas. What is, do we have any use for argon? Inert atmosphere in bulbs and welding. There are some bulbs that contain argon. Okay. Then water vapor. Water vapor, the importance is weather formation and humidity. Humidity is the level of moisture in the air. So water vapor determines how humid an environment is. If there is less moisture in the air, the place will not be humid. It will be very dry. Okay, especially during a dry season, for instance. Water vapor reduces. During rainy season, you have more in the atmosphere. So these are constituents of air and their uses. Okay, please, you still have to go through them. They are very important because you can see questions that just say one of these options, they will list the option. One of these is not a use, or is the use, anyone, is the use of oxygen as a constituent of air. Or the following constituents of air, one of the following constituents of air is, they will now start listing uses. You have to know which has a particular use that is being listed. So that's air. Air is not the topic. Air is not much. It's not much. I just want you to, what I want you to pay attention to very well as you study or as you watch this video is constituents of air. You must know them. Constituents of air. They are, let me list them again: nitrogen, oxygen, carbon dioxide, argon, that is noble gas, water vapor. Don't forget nitrogen, oxygen, carbon dioxide, argon, water vapor. So these are the natural constituents of air. Okay. Variation. Why do we have differences in proportion in different places? You also have to know. And the reasons are human activities, vegetation, humidity, altitude, seasonal variations. Those are the reasons. Then uses of these constituents. Uses of these constituents. You should be able to identify them. You know, it's CBT. It's not theory. You should be able to identify, okay, this is the use. They will not ask you to state the use. They can list the use and ask you to identify which constituent has that use. So it's as simple as that. Relevant notes that I've included here. Nitrogen has 78% of air. All right, nitrogen now is 78%. Oxygen is 21. Argon 0.93. Carbon dioxide is negligible. That is 0.03% of air. Then water vapor is variable because it changes from place to place. It depends on where you are. Water vapor is variable. It changes from place to place. So what I've just said is, you can see UTME frequently tests you on what? Why is air a mixture? Air is a mixture because it contains constituents that can be separated by physical means, and they have no chemical relationship, no chemical reaction, no chemical combination between them. Then fractional distillation and boiling points. Fractional distillation is the method used to separate the constituents of air, and the principle is difference in boiling points. Let me say that again. The method of separation is fractional distillation. The principle is difference in boiling points. Then you now have the causes of variation in air. They expect that you know the causes of variation here. I've already told you that. Then uses of these constituents of air. Uses of the constituents of air. Okay, so please take note of those things that I've just mentioned. They are very important. So we can move on to something else now. If you have any question, please ask before we move on. Any question from what I've just said
No,
about
sir.
air? Okay, no question. Who else is online with us apart from Shakiruddin? Who else is there? Is Precious there? Is Vera there? Is Balkisu there? Who is with us?
Yes, sir. Balkis with JAMB. Good evening, sir.
Oh, evening. You are welcome. How are you?
Fine, thank you.
All right. If there's no question, let's move on to a new topic. Okay. Please put your calculator close to you. Put your calculator close to you. I want to ask you guys a question even before I move on. Okay. Let's maybe at the end of the class now. Put your calculator close to you. Let's do something else. So we want to look at solubility. Solubility. Okay, so and what are we going to look at? We look at the meaning of solubility. We look at different types of solution according to the solubility of the solute. Then we look at
Sir,
how you, yes,
please, are we done with air?
yes.
Okay.
Okay, you just joined us, right?
Yes, sir.
Okay. Don't worry, once you watch the video, you should be able to understand what I've just taught about air. Okay?
Okay, sir.
Yeah, it's very simple. All right, so I said we'll look at meaning of solubility. We'll look at the different types of solutions that you have according to the solubility of the solute in the solvent. Then we will now look at different ways of calculating for solubility. Okay, these three things are very, very important. So I want you to pay attention to them. Solubility, different types of solutions, and calculations of solubility. So those are the three things we want to deal with under solubility. So let's begin with meaning of solubility. They will not ask you to define it, of course, but you should know the definition because if I am the examiner, I can say the maximum amount of solute that can dissolve in a given solvent at a specific temperature is, then I will list the options. Since I can't ask you to define solubility for me, I will define it and see if you can identify that definition as the definition of solubility. Solubility is the maximum amount of solute that can dissolve in a solvent. I believe you have heard before, you have heard that a solution, there's a formula for solution. You have heard that solution is equal to solute plus solvent. I believe you have heard of that before. How many of you have heard of that?
Yes, sir.
Good. Now, solute is the solid or whatever that you are dissolving, while solvent is the dissolving medium, the medium you are using to dissolve. For example, if I pour salt in water to dissolve the salt, now that salt is the solute, the water is the solvent, that's the dissolving medium, the solvent. Now, both of them together now gives me a salt solution. Okay, it's no longer water, it's no longer salt. You call it salt solution. Okay, that is solution. So the maximum amount, once I say solute now, I just explain that so that you know what I mean. When I mention solute, when I mention solvent, you have an idea already. Solubility is the maximum amount of solute that can dissolve in a given solvent at a specific temperature. Okay, the maximum amount of solute that can dissolve in a given solvent at a specific temperature. Each chemical substance that you know has its solubility. That is, there is a particular amount that will dissolve in a solvent at a particular temperature, which means if you bring in higher amounts, if you bring higher amount of solute than that solvent can dissolve, not everything will dissolve. That's what that definition is saying. So solubility is the maximum amount of solute that can dissolve in a given solvent at a specific temperature. And how do we express solubility? Solubility can be expressed as a mass concentration. Please take note, as a mass concentration or as a molar concentration. Mass concentration is grams per dm cube. I've seen questions. Of course, you must have come across questions even in WAEC and in UTME and post UTME. You can ask questions. You can be asked questions like the solubility of this also compound. They will write the substance. The solubility of this substance in gram per dm cube is what? Or the solubility of this substance in mole per dm cube is what? They are different. Those two questions, gram per dm cube, mole per dm cube, are the different expressions that you can give to solubility. So what do you do? We will see that now. When I ask you a question that this with gram per dm cube, how do you go about it? When I ask you a question that this with mole per dm cube, how do you go about it? So example of solubility is, I just told you that each chemical substance has its solubility, is soluble in a solvent at a particular temperature. For example, sodium chloride is soluble in water at 25 degrees Celsius. What amount? What amount is soluble in water? 36 grams of sodium chloride is soluble in 100 grams of water. 36 grams of sodium chloride is soluble in 100 grams of water at 25 degrees Celsius, okay? Which means if I bring 50 grams of sodium chloride to 100 grams of water, it will not dissolve. A major part of it will not dissolve. That is just it. You have exceeded the amount, the maximum amount that can dissolve in 100 grams of water. So I also want you to take note of something. What are the density? Please pay attention very well so that when you watch the video later, you can flow. Okay, it's easy for you to absorb what you are watching. The density of water is 1 gram per cm cube, 1 gram per centimeter cube. Now, that density tells you that 1 gram of water is equal to 1 cm cube of water. This information I've just given you now, you need it a lot in solubility. 1 gram of water is equal to 1 cm cube of water, which means if I have 100 grams of water, the volume will also be 100 cm cube of water, okay? Which means if you measure 100 cm cube of water, you don't need to weigh it. You don't need to weigh it. You already know the mass. You already know that the volume is equal to the mass because the density of water is 1 gram in 1 cm cube. So if I also have 100 cm cube, it means I'll have 100 gram as the mass of 100 cm cube of water. Why did I say this? Why did I say this? Because in questions, they can give you a question that will just give you the amount of water they will give you in mass. They expect that you know that the mass of water is also equal to the volume of water. So if you don't know that that mass you have been given indirectly represents the volume of water, you will not know what to do with the question. Don't forget that. Keep that in mind. All right, let's move on. Let's move on to types of solution according to the solubility of the solid. Types of solutions. You have saturated solution. saturated solution. Okay, saturated solution. So what I want you to note is the difference between these three types of solutions that you can have according to solubility. A saturated solution contains maximum solution at a given temperature. It contains maximum solute, at a given temperature. What does that mean? It means, for example, that example of sodium chloride that I gave, solubility of sodium chloride in water is 36 gram per 100 gram of water. That is 36 gram of sodium chloride will dissolve in 100 grams or 100 cm cube of water. That's a saturated solution. But if I exceed that 36 grams, let's say I now do 50 grams of sodium chloride, I want to dissolve it in 100 grams of water. I've exceeded the maximum solute. And when I do that, what I'm going to have is I'm going to have a super saturated solution because the 100 gram or 100 cm cube of water cannot dissolve more than 36 grams of sodium chloride. So if I have more than the solvent can dissolve, you call it a super saturated solution. Don't forget, if I have more than, I'm still using that sodium chloride as my example. So normally 36 grams of sodium chloride will dissolve in 100 grams of water. That is the highest, 36 grams. So if I go beyond 36 grams, that 100 cm cube of water can no longer dissolve the mass as long as it's beyond 36 grams. So what you are going to have is a super saturated solution. A super saturated solution contains more solute than it can dissolve at a particular temperature. Unsaturated solution now contains less than it is able to dissolve. For example, if I have 20 grams of sodium chloride and I want to dissolve it in 100 cm cube of water, 20 grams, 100 cm cube of water can dissolve up to 36 grams of sodium chloride. But if I'm now using 100 cm cube to dissolve 20 grams of sodium chloride, I'm going to have an unsaturated solution, which means more can still be dissolved. I can add more sodium chloride, like 16 gram. I can add 16 gram more of sodium chloride, and it will still dissolve. That is an unsaturated solution. An unsaturated solution can still dissolve more solute. Why? Because it contains lower amount of solute than it should. So there is still space to dissolve more. A saturated solution is the amount that it needs or the amount it can dissolve at that temperature. A supersaturated solution has more than. So you discover that a part of the solute will dissolve because it is more than the solubility. Don't forget those differences, okay? It's very simple. Saturated solution contains amount of solute that it can dissolve at a given temperature. Unsaturated solution contains less amount of it can dissolve at a given temperature, which means it can still dissolve more. A supersaturated solution contains more solute than it can dissolve at a given temperature. Don't forget. Unsaturated is less than, supersaturated is more than, saturated is equal. Okay. A saturated solution is a dynamic equilibrium. Okay. What do I mean by that? Let me just explain that. A saturated solution is a dynamic equilibrium. What do I mean by dynamic equilibrium? It means you have equal amount of solute, the exact amount of solute that a given amount of solvent can dissolve. For example, I can this 36 gram of the sodium chloride is the amount of solute that 100 grams of water, the solvent, can dissolve. So this solution will be at dynamic equilibrium. There is equilibrium in this solution because you have not exceeded what is expected. Okay, so you have an equilibrium. All right, that is what it means. If I say it's saturated, it's only a saturated solution that can be at a dynamic equilibrium. Don't forget. Only a saturated solution can have a dynamic equilibrium. Only a saturated solution. So let's look at the expressions of solubility now. Solubility can be expressed in moles per dm cube. I've said that before, or grams per dm cube. So, and the relationship between these two expressions, mole per dm cube and gram per dm cube, the relationship between them is that mass concentration, which is gram per dm cube, is molar concentration times molar mass. Please note that formula. That formula is very important. Okay, because they can give you they can give you solubility in gram per dm cube and ask you to calculate the solubility in mole per dm cube. This is the relationship you use. Or they can give you solubility in mole per dm cube and ask you to calculate solubility in gram per dm cube. Or they can give you values that will enable you calculate any one of these two, and then they will ask for the other one. They can give you some values in the question that will enable you to calculate gram per dm cube. Then the question will ask you for mole per dm cube. That's how exam questions are set. Okay, just to test how you reason. We'll see examples, okay? We'll see examples. All right. Let's see. Effects of temperature on solubility. Effects of temperature on solubility. How does temperature affect solubility? One, solubility increases with temperature. Solubility increases with temperature. If you want a solid to dissolve very fast, increase the temperature. Okay, solubility increases with temperature. That is for most solids. The same thing with liquid also, but less solids and gases usually are the ones that dissolve in a solvent. Okay, so we will not involve liquid in this case now. In gases, solubility decreases with temperature. Please, you can see they are not the same now. In most solids, solubility increases with temperature. Don't forget. You see, your UTME syllabus wants you to know these things. That's why I keep saying don't forget, okay? Candidates should be able to, these things that I'm telling you, that is how your syllabus puts it. Candidates should be able to explain the effect of temperature on solubility. So in most solids, solubility increases with temperature. In gases, solubility decreases with temperature. So an example of solid now. Sugar dissolves more in hot water than in cold water, if you have noticed, right? If you have noticed, if you put sugar in water, if you want it to dissolve very fast, just apply heat. You discover that it dissolves faster. It will take longer to dissolve in cold water than in hot water. So you see, most solids dissolve faster at high temperature. Okay, don't forget that. At high temperature. The exception about solids now increasing with temperature. You discover that I said most solids. I did not say all solids. So this exception is very important. Most solids. What is the exception? Calcium, tetraoxosulfate 6. Calcium sulfate. Calcium sulfate is a solid, but the solubility of this calcium sulfate decreases with temperature. You see that? So that exception is important. Calcium sulfate decreases, the solubility of calcium sulfate decreases with increase in temperature. As you are increasing temperature, the solubility of calcium sulfate will be falling, it will be decreasing. So which means if you want calcium sulfate to be very soluble, you decrease the temperature. But if you want it to be insoluble, you increase the temperature. This is unlike other solids whose solubilities increase with temperature, with increase in temperature. You see that for other solids, as you are increasing the temperature, the solubility will be increasing. That means the thing, whatever it is, will dissolve more. But calcium sulfate is the opposite. Don't forget that. Relationship between solubility and crystallization. Okay, cooling a hot saturated solution decreases solubility. What does it mean? If you have a saturated solution that is at high temperature, like you dissolve a solid at a high temperature, okay? Let's say you add sugar to water at a high temperature, let's say hot water, you add sugar to hot water. If you allow it to cool, the solubility of that sugar will decrease. That's what that first statement means. Cooling a hot saturated solution decreases solubility. And when that happens, if it's a saturated solution where you have the exact amount of solute that the solvent can dissolve, once that cooling takes place, that solute will start to crystallize out. It starts turning back to solid. That's what it means. Okay. That solute, excess solute crystallizes out. Crystallization is reverse of dissolution. So which means if you dissolve something in a solvent, you dissolve a solute in a solvent, to get it back, you carry out what is called crystallization. Okay, crystallization is a reverse of dissolution. Don't forget that if you have a saturated solution that is at high temperature, it is easy to get back your solute by allowing that solution to cool down. Okay, once it cools down, once the temperature falls, it will crystallize, the solute will crystallize back to solid. That's what it means. That's what is called crystallization. It will turn to something like crystals. Okay, now crystallization and recrystallization. Crystallization can be used for purification of solids, okay? Because when you dissolve this solid in solvent at a high temperature, contaminants might be there. If you allow it to cool down, possibly the contaminants may not crystallize. It's only the pure solid that will crystallize. So it will leave the contaminant out. That is why crystallization can be used for purification of solids by cooling a hot saturated solution. Recrystallization is you are repeating the process of crystallization so that you can achieve a higher degree of purity. Okay, repeating the process of crystallization is what is called recrystallization. So impurities will remain dissolved. Like I've just told you, it's only the pure substance that will crystallize once the solution cools down. Once the temperature falls, is the pure substance that will form crystals. The impurity will remain the same in the solvent. Don't forget, don't forget. So solubility of salts. Solubility of salt. This one is also very important, okay? Because I've seen questions where they will say one of the following salts is soluble in water, or one of the following is insoluble in water. How do you know which salt is soluble in water? How do you know which one is insoluble? Okay, or you can have a mixture of salts. They can tell you two salts were mixed together and they will give you the salts. So which of them is soluble? Which one is insoluble? How do you know? This is it. All triisonitrate 5 salts are soluble in water. All. That is, what do I mean by triisonitrate 5? NO3. Any salt you see that has NO3 in it will dissolve in water. Don't forget. All triisonitrate 5 salts are soluble in water. Common salts of sodium, potassium, and ammonium are soluble in water. Common source of sodium, for example, sodium chloride, sodium sulfate, potassium chloride, potassium sulfate, sodium carbonate, potassium carbonate, ammonium chloride, ammonium carbonate, ammonium sulfate. You see, they are all sorts of sodium, potassium, and ammonium. Those salts are soluble in water. Okay, don't forget that. All trioxynitrate 5 salts are soluble in water. Salts of sodium, potassium, and ammonium are soluble in water. Most chlorides are soluble, most are soluble except silver chloride and lead chloride. Silver chloride and lead chloride are not soluble. Others are soluble like copper chloride, barium chloride, magnesium chloride, aluminum chloride. They are soluble in water. Most sulfate that is SO4. SO4 is sulfate or tetraoxosulfate 6. Most sulfate, so if you see a salt having SO4 as part of the chemical formula, most of them are soluble except these three. The exceptions are three. You have lead sulfate, calcium sulfate, and barium sulfate. Lead sulfate, calcium sulfate, and barium sulfate. Those are the exceptions. These three are not soluble in water. Then insoluble salts, most carbonates and hydroxides. Most carbonates and hydroxides, they are insoluble in water. Except, we have already said the salts of sodium, potassium, and ammonium are all soluble in water, right? So the exception to these insoluble salts now is salts of sodium, potassium, and ammonium, which means any other salt that you have that is not of sodium, that is not of potassium, that is not of ammonium, and yet it's a carbonate salt, that is CO3. Carbonate is CO3. When you see salts that have CO3, and it's not sodium carbonate, it's not potassium carbonate, it's not ammonium carbonate, just know that salt will be insoluble. For example, calcium carbonate, copper carbonate, magnesium carbonate, aluminum carbonate, iron carbonate, name them, they are insoluble. And hydroxide, for example, aluminum hydroxide, copper hydroxide, iron hydroxide, magnesium hydroxide, they are insoluble in water. So you have to know that. I simplified it here so that it will be easy for you to memorize. All NO3 salts are soluble in water. Okay. All salts of sodium, potassium, and ammonium are soluble in water. Okay. Most chlorides except silver chloride, lead chloride are soluble. Most sulfates are soluble except lead sulfate, barium sulfate, and calcium sulfate. Then what about the insoluble salts? All carbonate salts and hydroxide salts are insoluble except salts of sodium, potassium, and ammonium. So the third thing we will look at is, or the last thing, under solubility now, is calculation. How do you calculate solubility in gram per dm cube and mole per dm cube? So this is where you use your calculator that I asked you to take with you. All right, are we still together?
Yes, sir.
Okay, thank you. Is Balkis still with us?
Yes, sir.
All right. So it's not hard. Who else is there? Who else is online with us? Okay, so this calculation is not hard. Okay, calculations on solubility are not hard. Very simple and straightforward calculations. So okay, let me simplify it for you further. I told you that there are two ways to calculate for solubility. So let me simplify further. Take note. There are two ways. So the first way is, or one of the ways, it may not be the first, is you can be asked to calculate solubility in gram per dm cube. Another way is you can be asked to calculate solubility in mole per dm cube. So if you're asked to calculate solubility in gram per dm cube, how do you do that? What do you do? What you do, the formula is this, okay? So if I want to calculate solubility in gram per dm cube, like I'm given the values that I need in the question. So it's going to be mass over volume, mass over volume. They will give you mass in the question and give you volume in the question. You know, gram represents mass, volume, dm cube represents volume. So gram per dm cube means gram over dm cube, all right? So times 1000, because usually the volume you will be given will be in cm cube. So, and this unit is gram per dm cube. So you can't work with that volume like that. You have to convert your answer later by multiplying by 1000. Okay, mass over volume times 1000, that is gram per dm cube. Don't forget that. Then if I'm to calculate the solubility in mole per dm cube, so it will be mole. That is amount. You'll be given the mole in the question, or they will give you the mass and the molar mass. Remember that you can calculate mole, amount of a substance, in mass and molar mass. You can calculate the amount of a substance using mass over molar mass. Don't forget. So they can give you the mass and molar mass of that substance in the question, and they're asking for the solubility in mole per dm cube. Okay, so you first of all calculate the number of moles, that is mass over molar mass, before you now use this formula of solubility to answer the question. So let's see if we can have a question like that now, just for you to understand. So you can see if it is gram per dm cube, you divide mass over volume multiplied by 1000. If it is mole per dm cube, you divide mole by volume multiplied by 1000. So if you are not given mole in the question, you have to calculate for mole. And how do you calculate for mole? Mass, that's reacting mass over molar mass. That's how you calculate for mole. So let's see this question now. Let's see question number one. So let me just extract the question so that we solve it together. So this is the question. If 8.2 grams of sodium hydroxide dissolves in 200 cm cube of water, what's the solubility? What's the solubility of sodium hydroxide? This is how they normally ask question. They can ask you what's the solubility of sodium hydroxide in gram per dm cube. So this is a question that we want to solve. If 8.2 grams of sodium hydroxide dissolves in 200 cm cube water. Remember that I told you that the amount of water can be expressed both in volume or in mass. This 200 cm cube, they may not give it directly. They can say in 200 grams of water, in 200 grams of water. And it's volume that you need to solve the question. But if they have given you 200 grams, you already know that the mass of water is equal to the volume of water. Please don't forget that. I've said it again now. Don't forget. Take note. Now, for me to answer this question, since they're asking for solubility of sodium hydroxide in gram per dm cube, my formula is gram per dm cube is equal to mass over volume. You don't need to write this formula if you are taking the exam or the test. You are trying to beat time. Mass over volume, everything multiplied by 1000. Okay, 1 dm cube is 1000. That is the reason for that 1000. 1 dm cube is 1000 cm cube. So my answer now, mass 8.2 That is the mass that you are given in question. 8.2, that is the mass of the solid, 8.2 grams. What's the volume of water that is dissolving this solid? They said 200 cm3 multiplied by 1000. So guys, press your calculator for me now. Somebody should press the calculator. 8.2 divided by 200. Press calculator for me. 8.2 divided by 200.
0.041.
0.041. You can see since there's 1 watt, 0.041 watt.
Just 0.041.
Okay, remember that I told you guys that in chemistry, three significant figures very important in calculation. So I have to show it as three significant figures. So this is my answer now. I added 0, right? 0.0410. If I just stop at 0.041, that is two significant figures. Okay, so this is it now. I've answered the question. It's as simple as this. Very straightforward. It's simple. It's simple. So
Times
let's check this.
1000 is 41.
What did you say?
I said times 1000, that is
Okay,
41.
you've not multiplied by 1000. Okay,
Yes, sir.
all right. You multiply by one. Please don't forget you multiply by 1000. That is a
No,
0.041
no, there's no zero
times
point there
1000.
again.
Times
Mm,
1000. You know,
yeah.
8.2 alone over 200 will give you 0.041, right?
Yes, sir.
So this one will give you what now?
41.
41. That is gram per dm cube. That is the solubility of sodium hydroxide. Okay, so let's look at the second question, the example 2. This one says, this one is too straightforward, but let's see now. Let's deal with it. Uh, this one says you should convert 0.05 mole per dm cube to gram per dm cube. You have to convert this to gram per dm cube. You are converting from mole per dm cube to gram per dm cube. What are you going to do? Remember I told you there is a relationship between mole per dm cube and gram per dm cube. If you still remember that relationship, it's what you can use for this conversion. I told you that you can be given the solubility in mole per dm cube and you're asked to calculate it in gram per dm cube. Or you can be given in gram per dm cube and the question is asking you to calculate it in mole per dm cube. So you use that relationship. Remember that relationship is this: gram per dm cube is equal to mole per dm cube times molar mass. That's the relationship. If you are forgetting, this is it again. Gram per dm cube is equal to mole per dm cube times molar mass. You can also make mole per dm cube the subject, right? Mole per dm cube is equal to gram per dm cube over molar mass. So now, what's the molar mass of potassium chloride? Of course, they expect that you know. Please take note that sometimes, if you have written ETME before, CBT, you discover that sometimes they will not give you the atomic masses that will enable you to calculate molar mass. I'm expecting you to know the atomic masses for the first 20 elements, all of them. So don't think they will give you all the information you need. I'm telling you in advance. Don't forget, you are supposed to know the atomic masses of all the elements, the first 20 elements. The first 20 elements, you are supposed to know the atomic masses. So now I want to use the atomic masses to calculate my molar mass. So let me calculate the molar mass first. So molar mass of potassium chloride, KCl. Atomic mass of potassium is 39. 39 plus chlorine is 35.5. So if I add them together, the molar mass of potassium chloride will be 74.5. Am I right? 74.5. Please press your calculator there for me just to confirm.
Yes, sir.
Okay, thank you. That's 74.5 gram per mole. Okay, that's the molar mass of potassium chloride. Now, I can go and answer the question. The question wants me to calculate, to convert mole per dm cube to gram per dm cube. So gram per dm cube is the question, is the unknown. So I've been given mole per dm cube in the question to be 0.05 times molar mass is 74.5. So multiply it for me. What do you have?
3.725.
Okay, 3.725, approximately 3.73 gram per dm cube. So you have just converted it. So 0.05 mole per dm cube is equivalent to 3.73 gram per dm cube of potassium chloride. This is it. So they can also reverse it. They can give you something in gram per dm cube and ask you to calculate the solubility in mole per dm cube. It's just a logic. They are just testing you, nothing hard. Okay. So let's look at another question. Let me write another question here. Let's say I give you, or the examiner gives you something like if 36 gram of sodium chloride dissolves in 100 grams of water. It may not be water, it can be any solvent. It's not only water that is a solvent, okay? Alcohol is a solvent, benzene is a solvent, toluene is a solvent, chloromethane, tetrachloromethane is a solvent. So it can be any solvent, but it does not matter. It's still the same principle. But usually it's water. I'm just telling you in case it's not water that you see. So if 36 grams of sodium chloride dissolves in 100 grams of water, calculate the solubility. Calculate the solubility in a gram per dm cube. Okay, let me even start from mole per dm cube. Mole per dm cube. B gram per dm cube. So there are two questions attached to this question now. So let me solve. You can see this. You can have a question like this. How do you solve? How do you solve? They say you calculate the solubility. The first solubility is in mole per dm cube. So what are you going to do? So I told you that if you want to, that's to answer the A part of the question now. Your formula for mole per dm cube is supposed to be mole over volume times 1000. Mole over volume times 1000. But if you look at the question now, you are not given mole. You are not given mole at all. So, but they gave you some values in the question that can help you to calculate the mole. So let me calculate the mole now. Mole is equal to mass over molar mass. I've told you this just now. Mass over molar mass. So mole is equal to mass is 36 grams. 36 over molar mass of sodium chloride. You have to calculate it. So what's the molar mass of sodium chloride? Molar mass of sodium chloride. Please let me repeat it. Go and look at the atomic masses of at least the first 20 elements in the periodic table. So sodium is 23, chlorine is 35.5. So if I add, it will give me 58.5, 58.5 gram per mole. So 36 over molar mass now is 58.5, which I've just calculated. So that will give me the mole. So 36 divided by 58.5. Who can answer that for us? Press calculator. 36 over 58.5.
0.615.
0.615 mole. Okay, so we have gotten our mole now. So let's go back to our formula. The formula is mole per dm cube. Mole per dm cube is equal to mole 0.615 over volume. The volume you are given in the question, you can see they gave you 100 gram of water instead of 100 cm cube. That was what I told you. So you just change it to 100 cm cube. Your volume will also be 100 cm cube. You already know the reason. The mass of water is equal to volume of water. So 100 gram of water will also be equal to 100 cm cube of water. So mole per dm cube is now 0.615 divided by 100 will give you 0.00615 multiplied by 1000. So if you press your calculator, you are going to have, what are you going to have? That should be
6.15.
6.15 mole per dm cube. You have answered the A part of the question. So who can tell me how will you answer the B part of the question now?
We use the gram per dm cube formula.
Okay, use the relationship between them. Gram per dm. Since you've already gotten mole per dm cube, just use the relationship between them. Gram per dm cube is equal to mole per dm cube times molar mass. So gram per dm cube is equal to mole per dm cube that you just calculated is 6.15 times molar mass is, that's molar mass of sodium chloride, that is 58.5, yes, 58.5. So multiply, what are you going to have? 6.15 times 58.5.
359.775.
359 point what?
775.
775. So I can just stop at 360 approximately. 360 gram per dm cube. That is that. Do you understand what I've just done?
Yes.
Balkisu, do you understand?
Yes, sir.
Okay, so solve this for me quickly. Now it's your turn to solve questions. So question number one. Question number one. If 20 grams of sodium carbonate dissolves in 50 grams of water. Calculate solubility, calculate the solubility in A mole per dm cube, B grams per dm cube. So let me even give you the atomic masses, okay, so that you will not be confused. Sodium is 23, but in CBT you may not be given. Sodium is 23, carbon is 12, and oxygen is 16. So quickly solve, and tell me your answer. If 20 grams of sodium tricarbonate 4 dissolves in 50 grams of water, calculate the solubility in mole per dm cube and in grams per dm cube. Are you true? Just follow the previous example, the last example. Yes, where are you? Balkisu, which one have you done? Is Balkisu with us?
Yes,
Hello,
sir.
Balkis. Okay, okay. Which one have you done?
I'm in the first question.
Okay. Is it hard? Is it hard?
I got 7 per DM cube.
Okay. What of the mole per dm cube?
7.84
What of
mole
gram
per
per
DM
dm
cube.
cube? What of gram per dm cube?
400, 400 gram per DM cube.
Okay. Let's wait for Balkisu. So you have to calculate the molar mass. That is 23 times 2 Na2CO3. No, Na2, which means your sodium, you have two sodium atoms there. Then carbon is 12. Oxygen is, you have three oxygen atoms, so it will be 16 times 3. So if you add everything together, if you press your calculator, I think you are supposed to have a 106. Am I right? Is that what you have? 106, the molar mass of sodium carbonate should be 106, right? Shakiruddin, what's your molar mass?
No, I did times the 2 and 3.
Okay, you have to do that. You have to. Na2, that 2 is for sodium, so it means sodium has two atoms. O3,
Sir,
yes, Balkisu.
I get 0.392 mole per DM cube.
Okay, what of gram per dm cube?
7.84.
Okay, so let's see now if there's any need to make corrections. I'm solving my own now. So my mole is equal to mass, that is 20 grams over molar mass. Molar mass is 106. So 20 divided by 106. Press calculator for me. Balkisu, 20 divided by 106. Press calculator for me. 20 divided by 106.
Sir,
Yes, I'm with you.
I'm not seeing the screen. Let's go.
Oh, okay, it's your network. Don't worry, it will show now. It's your network. Can you see it now?
Yes, sir. It's
Okay,
0.188.
0.188 mole. Okay, so now that I've gotten mole, formula for mole per day.
It's zero.
Yes, 0. Point what?
Yes, sir.
Okay, so you know formula for mole per dm cube is mole over volume times 1000. So my mole per dm cube will now be mole is the one I've just calculated. That's 0.188 over volume volume of water in the question is 50. They gave you 50 grams, which is the same thing as 50 cm cube. 50 grams is the same thing as 50 cm cube. Then times 1000. So press calculator for me. What are you going to have? 0.3
3.76.
you have multiplied by 1000, right?
Yes.
Okay, 3.7. Is that what you have? Balkisu, press your own calculator. Let me see. We are waiting for you. First press 0.188 over 50. So whatever you have, multiply it by 1000. Are you with your calculator there? Hello, can you hear me, Balkisu?
Yes.
Oh, okay. What do you have? What do you have? Balkisu, are you with us? Hello. All right. Maybe it's our network. So we have come to the end of today's class. If you have any question, you can ask. If you have any question, you can ask from what we have just done. Shakiruddin, any question? Any question, Shakiruddin? Shakiruddin,
No, sir.
unmute.
No question.
Okay. Balkisu, I'm waiting for your response. I can't hear you. All right, all right. Have a blessed night. I will send the note, the presentation now, this PowerPoint to the group. I believe Dima will also send the video to the group for us to review again. So if you have questions, send your questions to the Telegram group. Have a wonderful weekend ahead.
Okay, thank you, sir.
Okay, good night. Balkis, I did not hear you before. Now I'm hearing you.
I say good night. Thank you, sir.
Your final answer, you did not tell me your final answer. I said you should press your calculator. I did not hear you.
Sure. I said it that time.
Okay, what did you say? What was your answer?
I think about the soil.
Hmm. Your grandpa DM cube is what? All right. Good night.